Okay, page 393, review of Pythagorean theorem. So we know a squared plus b squared equals c squared is the formula that we use when we're missing one side of a right triangle. A, B, and C are the lengths of the sides. A and B are the legs. They make the L, the right angle. And side C is the hypotenuse across from the right angle. It's the longest side. So how are the hypotenuse and the legs of a right triangle related? There are a lot of different answers. You could say something like the two legs, A and B squared, like A squared plus B squared, and added together equal the length of the hypotenuse side C squared. You could say something like, I know the hypotenuse is the longest side of a right triangle and the legs are the shorter sides. There's a lot of different ways that you could describe that. So on number 2, we have triangle PQR has side lengths of 12.5, 30, and 32.5 centimeters. Prove that it's a right triangle. Well, if it's a right triangle, a squared plus b squared really will equal c squared. Remember that side C is the longest. That's the one that's most important. So we're going to label the longest one as side C. A and B are just the other two sides, so plug them into the formula. 12.5 squared plus 30 squared equals, that's a question mark over that, 32.5 squared. So we're just trying to see if they equal each other. So remember, we draw our line through the equal sign. And I'm just going to kind of zigzag it here. You would add up squared, add them, and then you would clear your calculator. What's 32.5 squared? And notice that they actually match. I put that wrong. Sorry, let me fix that. Those numbers actually match. So you would say yes. This is a right triangle. Okay. Because a squared plus b squared really does equal c squared. Number 3, if she knows just two lengths of two sides, or the lengths of two sides of any triangle, she says she can find the length of the third side by using the Pythagorean theorem. Is she correct? The key word right here is any triangle. And the answer is no. Pythagorean theorem only works for right triangles. On number 4, if you have this triangle, remember the right angle points, it forms an arrow pointing to side C. So I know side C is 8, the other two are A and B. It really doesn't matter which you put where. As long as you have C in the right spot, you're good. I put 4 in for A. So I wrote my formula, I plugged my numbers where they went, and I'm trying to find the other leg. In this case, I used B. So I square my numbers. I had to subtract 16, and then to undo squaring square root of 48 is 6.92. And it says round to the nearest tenth, so that would be about 6.9 centimeters. If you take a look at number 5, I have to draw this, and it says the legs, so that would be A and B. The hypotenuse is side C, it's the longest side. Always double check that your answer is longer. If you're getting side C, that it is in fact longer than the legs. A squared plus B squared equals C squared, add, and then we have to take the square root to get C alone, and I get 7.5 inches. Don't forget to label inches. And which ones represent the sides of a right triangle? We want to see which ones where a squared plus b squared really does equal c squared. So I just did one example for you. You would go through them and you would see if a squared plus b squared really does equal c squared. Just make sure you choose the longest side for c and check them all this way. So if we just did this, 6 squared plus 9 squared equals square root of 117 squared, I'd put them in my formula and see if they match. 6 squared is 36 plus 9 squared is 81. That's 117. When you do 1 square root of 117 times itself, you just get 117. The little trick is when you square square root, remember squaring and square root are opposites and they cancel out. And you're just left with square 117. So because this is a true statement, it works. Yes, it's a right triangle. And you would just do that for all of them. And the only other one that worked was this one right here, 13, 84, and 85.